All right, it is 8:15, so we're gonna get started. Um, mm, all right, today's lecture is lecture 7, Node.js and NPM with Samsung Node Package Manager. I'm gonna try something new this lecture. I'm trying going a little bit slower, and also I'm gonna allow you guys to type everything I'm typing, so you can sort of type it. Yeah, so if you have a computer, take it out. I'll make sure you can follow along with everything I'm typing. Yeah, I should be able to run it. Yeah, just get a computer, and we won't start a demo right away, but yeah, just get it ready. So, what is Node.js? So you run a lot of JavaScript now already on computer now. But as you can see, it's really different enough from what JavaScript you learn about and JavaScript that is like the Node.js. So JavaScript you learn about can only run on the web. Other languages you may be familiar with, like Python or Java, they can run on the command line, right? You can run them as programs whenever you want. So Node.js essentially allows you to do this with JavaScript. That's pretty cool. That wasn't originally the case with JavaScript, but they added it. So that's why it's called Node.js, not just JS. So you can download it. I'm sure you already have it though, because you've been running React, and that comes with Node.js. So you don't need to install Node.js apart from that. You can check if you have it by just opening your terminal and running Node. That should tell you whether or not you have it. NPM stands for Node Package Manager. I'm sure you've used it as well. It basically allows you to install packages. So it's kind of like if you use pip for Python, it installs packages for you. It's great. And also, apart from pip doesn't do this, but NPM does, it kind of sets up your whole project environment, which is pretty cool. You'll see that in a second. Yeah, like that. So you type things into the command line, like npm install 3. It does a bunch of cool stuff, and you'll be using it. Yeah, so what's cool about Node.js is that it allows you to run JavaScript in a far more powerful context. So when you run it in your browser, you can only really access the screen. You can maybe do some pop-ups and download files, but that's about it. You don't have access to the file system. You don't have unfiltered access to the internet. You don't have access to, for example, starting a web server. A lot of things you can't do that you will want to do, that you can do, for example, with Python, right? Because it runs just in your computer. With Node.js, you can do that too. But there's things you can't do anymore. So with Node.js, you're just running in the command line. Just imagine a bunch of text, right? So you don't have the website anymore. It's just JavaScript. So you can't do stuff like document.l and by the anymore. It doesn't make sense anymore because it's there's nothing I need to document. There's nothing to change. That makes sense. I'll show you in a second. So the first example of something that I'm going to show you how to build Node.js is a web server. So you've been making a lot of websites, and GitHub has been posting them for you, your charts, very nice stuff. However, it is important to learn how to make your own websites, and what's actually going on when GitHub whenever you ask GitHub for your website, it sends it back to your client and it shows it for you. What is going on there? Well, this is what's going on. There's a computer called the web server over here, which is always on. This computer is somewhere in GitHub servers. It's permanently on. I have your files and waiting forever until suddenly one of us comes in to grade your project over here, and we send a request to GitHub's servers, and it sends back your website. And so your website is supposed to use a bunch of HTML and CSS and JavaScript and React. And my browser Chrome for interprets it and this goes. So that's what's going on. But note that it's a computer that's always on. In order to have a website, you have to go have a server. What's cool about this is once you have a server that's giving someone your website and the website is running on your computer, you can use the server for more stuff. So hypothetically, imagine I give the user's browser a client, okay, which I instruct to make another request to my server, apart from that original one to get the website itself. For example, imagine you give the user a login form, And that login form, when the user clicks submit, it sends another request to that server, which already gave the website. It sends another request to that server asking, hey, look, is this username and password a valid user? And the server responds, yes, it is. The server does a bunch of stuff, right? It clicks in the database, it's like, oh, is it here or not? And it says to the client, yes, it is. And the client now says, okay, perfect, that means I'm logged in. So servers both give you the website with your coding, and they can also do other stuff if you just ask them to do other stuff. And I'll show you, this will become complete in a second. But the main point is the server is always on. Basic server always on. Browser only on when you are accessing the website. Cool. So now is the moment where I will ask everyone to grab their computers and open them. This will be a short lecture in total because we're doing checkoffs at the end, I think. So yeah, I get hyped for that. So yeah, so I'm going to ask you to make a new VS Code or whatever you're using project. And in the project, I'm going to ask you to make just a JavaScript file. So I've made here a JavaScript file. I've made here a JavaScript file, which is called start.js. You can call yours whatever you want, .js. And I'm also going to ask you to open the terminal down here. And if you don't have a laptop, you can follow along with your mind. You can just run this in your head. Shouldn't be too hard. And give 30 more seconds. Anyone just done? Raise your hand. All right, nice. Is anyone just not doing this because you don't feel like it? Raise your hand. Oh yeah, so good point. So make a new file called something.js. I called mine starter.js, and then open the terminal. I think everyone is done. So now what I'm going to ask you to do is just type in some JavaScript code in here. So I put console log 42. Of course, you've done this already in the browser, right? It logs 42. You might have even done this already with Node. Probably have. And I'm going to ask you to go to the terminal and type in Node. So save the file. Make sure it's saved. It'll tell you if it's not saved up here. And then type in Node, and then just type in the name of that file. And it should do exactly what we tell it. So I did print 42. You can do print whatever you want. And it'll print it. So console log. Not print. 5 minutes print. This is console log. Hopefully that worked. 5 more seconds. Change the print statement to whatever you want. You can add some if statements. Normal JavaScript, whatever you want. There's no screen though. There's just the output over here. No screen, just the output. All right, looking good. So that is Node. What you've just done is you just ran JavaScript in your own computer. That's pretty exceptional. It's relatively new compared to the lifetime of JavaScript, and it's really useful. I will show you why it's useful now. So what we're going to do is we're actually going to build one of these servers. So we're going to build the server that literally is basically what GitHub is doing, which is serving your website whenever anyone asks for it. So let's do that. I'm going to put my mic just down 1 second and I'll type this, except I'm going to type it so it's a little bit less intimidating. So that's how you import things in Python. I mean, in Python is different. I don't remember how it was, but I think you just import something, add something, or whatever. This is weird. This is like you're making a new variable and calling a function called require, which imports. It's kind of weird, but it is how it is. I'm going to import 2 things. Yeah, there you go. That's the other one. So I'm going to import express. I'm going to import course. And Express is the one that you really should be looking at here. If any of you are familiar with Django or with Flask, Express is that kind of thing. Basically, it's just a two-package library allowing you to create servers. And I will explain to you what a server is in this case. I'm going to wait 10 seconds. Copy. So next, what I'm going to do is I'm going to copy this one. So here we make a new Express app. Well, let me actually copy a few more things. Sorry. Copy this. There you go. So I'm going to make a new Express app. Blah blah. This is just boilerplate code. You can find it online. I did, and I not know this by heart. I'm just going to keep copying. I'm going to copy this. I'm just going to be 1 second. There you go. So we import Express. We tell Express to do some boilerplate stuff. I don't know how this works. We get app, and then we do app.get slash. So I'll explain that in a second. But basically, app.get is saying whenever anyone makes a request to our server, what we should do is handle a request and handle a request. And handle a request is a function I defined right before it, which basically just grabs that response object and it sends back hello world. You'll see what this does in just a second. It's pretty cool. I'm gonna leave it here for a couple dozen seconds. Yeah, so what a server is, it's just a program running in a computer, which is listening for connections. Making connection is really easy. Anyone can do it. Anyone can try to make a connection to your computer. That's why we have firewalls to block those connections. But if you remove firewalls and you start up this server right here, anyone can make a request. And whenever anyone does, you will respond hello world. That is what a server is. It respond to connections. Connections is like an atomic thing. You can just do it. Yeah. Yeah, so I did not explain TRS. Good catch. I will explain it in a second. For now, just type it out. Yeah, I will come back to it. I'm going to do one more thing. I'm going to put this one. So this one's weird. We're doing app.listen and some random esoteric number minus 3042. Other thing side. Minus 3042. The reason we need this is because the people who made this realize there's a possibility that you might want to have multiple servers on one machine, multiple things waiting for connections on one machine. So they created ports. This is port 3042. So I'm saying, hey, look, I'm going to listen not just for anything that comes to this machine, for anything that comes to this machine on port 3042. And when it comes, I'm going to handle it, and I'm going to send back hello world. Yeah. Oh shit! Wait, hold on. Yes. The answer is yes. So when you're done with this, or while you're doing it, do npm. So okay, yeah, this is a good point. About this. So before you make the file, what you're supposed to do, it doesn't matter the order, so it's okay, is you're supposed to do npm init. What npm init will do is it will create a project for you. So Pip doesn't have it in the Python. You have to do it yourself. You have to make a Python file. And we'll get to the just but whatever. You do npm init, and when you do that, Magnum will probably say it already exists. Oh no, it doesn't. It's done. So it'll ask you something like this, like package name, blah blah. Just keep pressing enter. It doesn't matter. Everything is irrelevant. And then it'll make it, and it'll make a couple of things. It'll make like this thing package like based on. Like this package localization. I'll just make a couple things, maybe not. But now what you can do is you can run a different command. Okay, so first of all, do npm init. Oh, you don't need to print 42 here. You can just print whatever you want. There you go. I'll put that. Is anyone lost, or should I scroll up, or anything? Yep. Yeah. So if you just press enter, it'll use the defaults. You can change them. I think most of them are just relevant. So that they also doesn't matter. You can just kind of skip it. All right. All right, I'm going to continue. So after you've done npm init, you can do npm install, or just I for short. And then there's one thing you need to install. You may have noticed you have to install also two things: Express and Course. You can do one by one. You can do both at the same time. So for the first one, Express. So you're gonna type something like this: npm install Express. To do that, this is similar to pip install. I'll keep it here. Though I already ran it, but I'll keep it here. Mine was really quick. Yours will not be that quick because I already had done it. So just go ahead and install it. And when you're done, install Course, spelled like CORS. This part might give an error. If it does give an error, unfortunately, you're kind of doomed because this will take like, I don't know, 5 minutes to 10 minutes to debug. So you can continue at home. And then Course the same. The npm install package, like the npm package manager is kind of buggy. It's like a few other alternatives now, like Yarn YARN, pretty cool alternative to npm. It's not buggy, sorry, that's how I'm saying it. You can get a lot of package dependency errors where like one package you already have depends on package designer it's like explodes. It's incredible. It just takes a while to figure it out. But if that doesn't happen, you should now have Express and Course. So Express, and then after you're done with Express, just run npm I Course. Like that. And you should stop. All right. Raise your hand if everything I've done, you've done. Nice. Pretty good. So now this should run. How do you run something? So npm, remember, is the package manager. Node is the Node.js is the execution runtime. If you think I want to run JavaScript, completely different things. npm is the fancy utility. Node is what actually does the magic. So you do node, and then you type in whatever your JavaScript file is called. Mine is called started.js. And when you run it, hopefully it doesn't give an error. I'm going to zoom out a little bit. You can see the whole file. So it should say whatever you printed down here. So I did server is moving for 3042. Make sure I think you should just use 3042. If your port is lower than 1,000, it might give an error. You have to use it, right? So there's a bunch of stuff. So just use 3042. But now, I'll come back to this in a second if you're not quite here. If you do localhost 3042, you should get a website. Says hello world. Try it. It's localhost 3042. So you use localhost if you just on your own machine. If someone else wanted to access the server on your machine, you type in the IP address of your machine. You can find the IP address of your machine. Sadly, your machine will likely block incoming connections because of your firewall. Because most machines, as they are sold to consumers, are not meant to be servers, so they don't enable these kind of connections. But if you hypothetically enable it, you could turn your machine into a server, and anyone could make connections to your machine and get the website. From inside your machine, you can obviously make the website. Yeah, localhost 340. And this is probably familiar to like when you're running the React project and like pops up for you. It's localhost something. Same thing as what we just did there, except we just actually did it. This is real HTML, by the way. Oh, yeah. You have to restart the file if you change shit, like restart the server. There, so now it's an H1. My point being that this rest.send over here, this is the entire HTML file. So if you actually built out this, I wanted to make it a real server, in here, you would put your whole HTML file, like body, head, links to other things, stuff like that. The whole thing would be in just this string. So that's how it works. This slash, going back to the slash, this is where you are. So right now we are in the slash. So put slash so you can imagine your indie slash. But if you go to like hello, this won't work anymore. It'll be like cannot get hello. Or small. Oh, you like cannot get hello. You have to be like, you have to say hello here, and then it'll work. So now I change that to hello, and this will work. But of course, the normal one won't work anymore. You don't need to copy all that, but that's just the point. So this is the path. If you want to handle multiple paths, so you want to have different paths on your website, you can just have different handlers. You can call this line multiple times and have different handlers for different paths. Does that make sense? Any questions? Nice. One more thing. The course. The course is not that relevant right now. Basically, there's like a bunch of. Wait. Does this work for everyone? Raise your hand if you have a website. Okay, it looks like half people actually. Cool. And I'm just gonna do one last thing. I'm gonna add something interesting. So, just to emphasize the power of servers as not just like the thing that gives you the website, I'm gonna do something. So I'm gonna make my bar here, and I'm gonna set it to like something, I don't know, 1. And then when I do rest.send, let me put this back to normal. I'm gonna be like incremental, yeah, nice. Hold on. Okay, so all I did is whenever I did rest.send, I now send incremental value and I concatenate the integer and then increment the integer. What does this mean? Every time I handle a request, I'm gonna do like incremental value 1. And then I'm gonna increase it. The next time I make a request, I'm gonna be like incremental value 2. So I'm gonna give a second to copy that. I'm add it to mine and change just this one. If anyone has any like theory questions or like questions about like what's going on here, just let me know. So this is what it does. So I restarted it, ran it again. Incremental value 1. All right, makes sense. So it was 1 to begin with. I had made a connection, so it should have incremented it. So now when we reload it again, it's 2. And next time 3. And if I close this and I open it again, it keeps it. Like it remembers value. It doesn't get lost when I close the website because the server is always running. It never stops running. It's here in the terminal. The client can go away and it can come back 3 years later. The server has been running the whole time, waiting for another connection with incremental value saved as 7, ready to give it when the client comes back. That is the key difference between the server and the client. The server is always running, so I can do cool things. Now, just to drive this point home, this right now, as we have it set up, looks like a server which is supposed to ping or send a request to whenever you want the website back. In this case, they'll picks up, it's incremental value. But it's like a server that like you put in here and you let Chrome make the request. Because what's really going on here is you're putting this address here and Chrome is making that request for you. We can make this request ourselves. And this part is going to be relatively quick if you don't have that probably have so much time. Well, we still don't have much time. So I'm going to do something relatively quick. You can follow me if you want. I started a new project. You don't have to. I just started a new project to drive the point that the client is really separate on the server. You can just make this HTML file wherever you want, next to the JavaScript file, and just go ahead and open it. So I'm just going to put a 42 in here. I'm not going to put anything as HTML file. And when I open it, there you go. And so just go ahead and make something.html. I made a new.html and I put a 42 in it and I opened it and it's here. Wait, raise your hand if you've done that. one person has done it. One person has done it. Congratulations, two. Congratulations, two people who did it. Great. Four. All right, I'm just gonna do this quickly because I don't think anyone cares. So anyways, what is the point here? So you have a button. Oh, notice I didn't add anything boilerplate like you had the button because actually nothing that we thought you actually matters. You can ignore all of it and just start coding. Pretty neat. So you have the button over here, you have on click, get stuff, and you have a get stuff start. It's a normal button that will run on function doesn't yet exist when I click it, and H1 with an ID. And now I'm gonna add all this script stuff. And so what is this doing? Get stuff, we defined it down here. So what it's going to do is whenever I click this button, it's going to run this boilerplate code I searched up and copied, which makes a request to, if you notice, the same address we're putting in our Chrome address bar. And then it's going to do some stuff, and it's going to do handle.stuff, which is up here. And that's going to run when the request comes back with stuff. Stuff is going to be whatever the server responds, whatever the server at this address, at this port responds. Happens to be my computer, port 3042, and we happen to have a server running, listening on that port. How I'm going to go and stuff is going to get that stuff, and it's going to do my h1.html equals stuff. Hopefully you know what that means, but essentially what it's going to do is it's going to grab this h1 and it's going to change what's inside of it to whatever the server responds to it. So let's try it. I will come back for the technical stuff. So this is what it will do. So you click that stuff, and it makes a request to the server, which is somewhere else. Notice this is not the server, right? The server, if we just ping it right now, it just returns incremental value. This is not the server. This is a different file, which when I click get stuff, makes a request to the server, gets whatever response, and puts it in an H1 tag. So it's big. Completely different file. In fact, it didn't even need to display it, but we chose to display it. So, but what's cool is every time I click get stuff, it goes up. And if I close this tab and I open it again, and I click get stuff, it remembers the value. Okay, so the point being that in order to remember anything for a user, you need a server. When Facebook remembers who you are, it's because they have a server running all the time with your information stored, so that whenever you ping them, they can say not incremented value 21, you can put your name there. Does that make sense? That is what's going on. They do it by very similar mechanisms. We just did it in, except they do more stuff. So that's the idea. Fetch the server, put it in the file, it appears. I'll leave this here for a second in case anyone wants to try it. All you need to do to make this HTML file work is open it. However you want to open it, I just double click it in my Explorer. Yeah. Any questions? Yeah. What happens when you don't Oh, this part over here. I'll just copy this off the internet. It's a part of the code that is required to fetch things. Specifically, the point is like what's really going on here is you're making the request, and then result is not action text. It's like it's the result blob. What does that mean? That means the result doesn't come back all at once. It's coming back over time from the server. So what we're saying is, hey, look, give me that result and just wait until the entire text has arrived and return back instead. Because we don't really care about speed that much. We don't want to get each individual character that comes in. We're just going to wait until the whole thing comes in. That's what we're saying there. And then when we're done with that, that's where there's two dot thens. So the first dot then is like, all right, every time it comes in, just accumulate it into text, and then put it on the screen. Yeah. Yeah. It's a very good question. So when HTML was designed 50 years ago, they hadn't thought that far yet. So what they did is they just made every element with an ID automatically defined in JavaScript as a variable with its ID. Kind of random, kind of esoteric. You can think about it as being something like this. Like that's what's going on behind the scenes, right? For every element of an ID, it's creating a variable of that ID. So you got to be careful. Sometimes you'll think a variable is not defined, and then it is because some random thing in your HTML happens to have ID equal to that. So you gotta be careful with JavaScript. There's a lot of weird things behind the scenes. But this one's pretty useful because it allows me to show you less code, which is less intimidating. But I guess. But yeah, you can put get element by ID. All right. Yes. You don't write what when you get stuff? Like that? Fair enough. So you're saying something like this, right? Like that? Yeah, that'll work too. So what we're doing is a shortcut. So this is, so if you think about it, this is like a, yeah, like, oh, dumb. So, this is a shortcut. What this is a function that will take in rest and it will run a function with passes in rest. But this function already expects to be passed in rest. So we just pass in the function without calling it into .net. Just by the way, needless to be complicated information. Then when it gets called, it will get called with rest, just like our function is getting originally called. But the point is, you can just think about it like that. This makes more sense to you. Yeah, this requires you to be pretty familiar with the arrow functions, which is why I kind of admitted it. All right, cool. And final part of functions. You have these 13 minutes. Yep. Fetch, good question. So fetch comes with JavaScript. Essentially what it does is it makes a request to a server at a port anywhere in the world. We're saying make a request to localhost, which is me, my computer, port 3042. Usually this will error because nothing is running on your computer, listening for requests on port 3042. But happily, luckily for us, we have this running here, which we ran and it's still running. I can stop it, but it's still running. And it's listening on port 3042 on my computer. I run it on my computer. If you typed Facebook's address into here, then you could get all of Facebook's source code back. Let me try it. Yeah, okay, so there's this like a security thing which doesn't let you do that. Fair enough. Let me try my own website. I don't think I put that security thing. Oh, it did. So, all right, let me see what website wouldn't have this. Which is Google? All of them? Yeah. We need, so yeah, this is by the way, if you read here, it says course, CORS. This is why we over here we had to have this course thing. This is basically saying, hey, look, I'm making a web server and I want anyone to be able to make requests to me. That's what we did. That's why our website works and Facebook doesn't, because Facebook doesn't have this line. Which is smart because that means our server, anyone in the world can make requests to. Facebook, no, unfortunately, we cannot. Or Google. Wait, hold on. Yeah, what? I don't know. So I honestly doubt it because I feel like all these come pre-configured. Oh, oh, hold on. That's pretty funny actually. So it is working, but it's just not working. Yeah, so here it is. Here's all the code. So the request did go through. Just let me log it. There it is. So there's all our code. It doesn't show up because it literally put it in the screen, and this renders to nothing. Like this is literally like if I just show you, it's here. See, it's all here. This is all web dev website. Put it all inside the H1. There's nothing here because of how web dev renders and works. It realizes it's not in the right place. It just doesn't render itself, unfortunately. But if we I call this my H1, it is no longer an H1. It's now a text area. No. There it is. So now we put all of web dev source code on this thing. Pretty cool. Of course, that's just because of a web dev here. Web dev is not an API. It's not something you're supposed to make a request from programmatically. You're supposed to put it in your browser. So it looks like gibberish from here. Ours, you are supposed to make a request from. We give sensible data back. Oh, because of HTTPS. There you go. Pretty cool. So our website is like web dev, except it's only accessible from our computer and also running on port 3042. Web dev is running on, you can hear that as no port because we didn't add the port, but it's port 80 by default. So web dev is running on port 80. Any other questions? Yes. Yeah, okay, good point. So for you that are thinking about this from the promise perspective, the only perspective. So fetch returns a promise, which we then say, all right, when that's resolved, run this function. And what this function is doing is it's taking the result from this promise fetch, and it's running a text function on it. What that tells the result log is to wait until the whole thing came back, and only then to wait until the whole thing comes back. But it immediately returns a promise. And because of the fact that this immediately returns a promise, this immediately returns a promise. So we can do that on that too. Because it's a promise chain. And then this rest is no longer a promise. It's no longer an object, it's straight up just a string. So we couldn't do any more chaining here. We just pass it on to our function. Yeah, it will make more sense if you do await with it. We'll see what's going on further. But yeah, that's kind of what's going on. Yeah. So that's just how fetch is built. You really have no choice. They built it with promises in mind. You can't really like the only I guess there's two ways of answering this question. First point is there has to be promises here because requests take time. Like you send a request to Facebook, as you may have noticed, it doesn't load instantly. In fact, Facebook's pretty goddamn slow site. So it takes a while. That takes a while, right? So you need to use promises. You couldn't just get the value from fetch and then immediately keep running the code because it hasn't loaded yet. So the promises are built such that it can be like, all right, once Facebook eventually returns to the same, blah, blah. Alternative to promises for that use case is callbacks. And callbacks will require you to pass in the function like another parameter. Not a thing. That's not how fetch was built. You can't do it. Yeah, that's about it. And final question. All right, well, class dismissed. Thank you for coming. And I'll see you guys never lecturing again. But maybe see you guys on Friday. All right. Oh wait, no, hold on. We have checkoffs. Checkoffs, stay, please. If you have to check off. What are we checking? Project. Software. Checking off. Product 2. Product 2. If you have finished product 2, please stay. Or product 1. Wait, okay, just let me check the website. Okay. Where's the large pizza? Oh, this one there? Rocks again? All right, cool. So I know some people have already checked this off, I think. So if you've already, is this what we're checking off? No, right? Anything else? Yeah, okay. So if you check this off, feel free to leave. I know I checked a bunch of people off in my discussion section, office hours. If you haven't checked it off, feel free to stay and check it off now. This is the worst due right now, right? So this is the last chance. Yeah, so if you want to check it off, stay. All right, thank you for coming. The code? No, this part? um, what code? Well, I'm not sure a word out. 4? 42 is what? No, it is 42. Well, someone said 4? So we'll go with 4. Just FOUR. Just straight up. All right, thank you for coming. And all the way up. You can come to any office hours and look at the right? Yeah, just come to any office hours anytime. No problem.